Okay, so we have done some molar mass problems in class before, but now I want to make sure we know how to do it so we can get into our conversions to moles and to and from molar mass and moles. All right, so in regards to molar mass, remember, always, let's go down a little bit, always round to the first decimal. All right, that's terrible writing. Sorry about that, but it's fine. All right, so if we do this, we are always looking for our particular atomic mass on the periodic table. So in this case, if we have NaOH, we are always getting it down to our base elements. Whatever elements are involved in this, we have to separate out, so we have to figure out the amount of each so we can find the mass of each, so we can figure out the total mass of the substance. Remember, law of conservation of mass says that an object cannot be created nor destroyed, so the mass has to be there from the original product or the original reactant. All right, so in this case we only have one sodium, we only have one oxygen, and we only have one hydrogen. So hydrogen's only 1, oxygen's 16 because it's 15.99, so it rounds up. And then sodium is going to be, let's see, we look at sodium. Sodium is 22.98, so that means it's going to round up to 23. So that gives us, we don't have to multiply anything by anything because we have 1, 1, and 1, so we're just going to add them all up. That gives us an answer of 40 grams. And there's 40 grams in every mole, so we can call that 40 grams per mole, or 40 grams are equal to 1 mole. Okay? So in the second problem, we have H, we have P, and we have O. Now, the nice thing is there's no parentheses, so we don't have to multiply anything in there. So we just have 3 H's. We have 1 P, and we have 4 O's. And now O is 16 based on what we saw last time. Hydrogen's 1 based on what we saw last time. We look at phosphorus. We see that it is 30.97, so that's going to round up as well. So we have 31. So that means we have to do our math this time. So we have 3, 31, and 16 times 4 gives an answer of 64. Wait, 64, 24, 40, yeah, 64. So 64, so we just add up our math together. So we have an 118 grams per mole. And that's our answer for the next one. So we have to do this in order to figure out how to get to our moles or to and from our moles. All right? Because eventually we'll have a couple steps to get in there. So according to this, each definition, we're going to take 1 mole to our molar mass if we're trying to get from mole to molar mass, and we know that that's what we're trying to get to. So we have, in this case, we're going to start off with a little bit. So this is going to be a little bit of work. It might take a little bit of time, but we'll get there. So if I have 3.4 times 10 to the negative 7 grams of silicon dioxide, I'm trying to figure out how many moles I'm getting to. So I know that I'm looking for 1 mole, because based on what I said last time, we're always equal to 1 mole no matter what, no matter which thing we're looking for of the 3. All right, so we just had to figure out how many grams there are in silicon dioxide. So I'm going to take my silicon, which is 1, I know, and then my oxygen, which is 2, and I know I have 16 oxygens, which means I have 32 oxygen for my oxygen. I look at silicon. Silicon is 28.08, so that's going to be 28.1. So if I add up the two together, so 28.1 plus 32, that gives me an answer of 60.1 grams per mole. And because of that, I'm really just flip inverting it to get to my moles, because I'm putting my moles on top. I know there's only 1 mole. I know there are 60 0.1 grams in that. So I can just do the math. So I can take 3.4 divided by 60.1, and I can take that, and I know that my answer will be times 10 to the negative 7th, because I don't need to add it on. I can just move it because it's just minusing 0. That's basically what it means, because 60.01 is just times 10 to the 0. So what I do is I take my 3.4, divide that by my 60.1. Be better if I didn't press clear. So let's go with 3.4 divided by 60.1. And so I have 5.057. Alright? Once I round up. Now, this is not correct, because I have to move the decimal place over 2, or I have to write out all the zeros, and that gives me an answer of 5.7 times 10. Remember, if I move from the left to the right, I have to take away 10, so that makes it a 10 to the negative 9th. And that's going to be moles of SiO2. Okay? And this is my answer. Alright, so next problem. Let's try this one. Now, I am going to want you to do all these, so make sure that you get on it. So if I have how many grams are in 1.11 moles of magnesium sulfate, so I'm going to take my 1.11 moles. I'm looking for grams. I don't know how many grams I have yet, but I know my 1 mole goes on the ground, so I can get rid of that. So I know I'm going to be in grams. So magnesium sulfate, if I have manganese has 3, because I have 3 there. Sulfur has 7, because remember, everything inside the parentheses gets multiplied by the number outside the parentheses. So I have 7, and then 7 times 4 for oxygen is 28. So this is going to be a big number, because if we look at manganese is 54.9, sulfur is 32.1, because it's 32.05, so we're going to round up, and then oxygen is still 16. So I take my 3 times 54.9. This is my 164.7. I then take 32.1 times 7. That gives me 224.7. And then I have my 28 times 16, which gives me 448. So that plus 224.7 plus 164.7 gives me a total answer of 837.4 grams per moles. So with that being said, I have my 1 mole there. I will now take my 837.4 and I can multiply it. So I'm going to multiply this by 1.11. Gives me an answer of, hit it too many times. So 837.4 times 1.11. So that'll be an answer of 929.5 grams of manganese sulfate. Big number, but that's how we do it. So it's a 2-step problem when we have our molar mass. It'll be very important for you to practice that. I suggest, if you don't have the paper from class, that you do all of these just for the practice. All right, make sure you do all of them. Good luck. If you have any questions, please email me. Thanks.